Have you ever gotten lost in the slow drip of a liquid motion toy on your desk? Well, it seems like researchers at the University of Oxford must have at some point or other. They recently adapted a 3D printer, one of those devices that builds solid objects a layer at a time, to form colorful objects from aqueous droplets filled with dye. But these aren't just any droplets. The tiny droplets have a diameter half the size of a human hair, and they're made of water surrounded by lipids, the fatty molecules that form the outer barrier or membrane of a cell. When the researchers, led by chemist Hagen Bailey, print their droplets onto a platform, they deposit them in an oil bath. Because of the repulsion between oil and water, the droplets stay intact, and the surrounding lipids ensure that the globs stick to one another, forming a network. The Oxford scientists think that someday this printing method could be used in tissue engineering. For instance, if the droplets were loaded with cells, the globular networks might be coaxed to grow into new tissue or even interface with existing tissue for wound healing. But that's not all the 3D printing method might be good for. The researchers also used it to make a shape-shifting structure. See this flower-like set of droplets? The ones on the bottom are filled with a high concentration of potassium chloride salt, and the ones on the top are filled with a low concentration. After they're printed, over the course of hours, water from the droplets on top flows into the droplets on the bottom because of a process called osmosis. When this happens for the flower-like droplet network, the droplets on top shrink and the droplets on the bottom blow up, causing the whole structure to curl into a sphere. This concept, the researchers say, might one day be used to trigger drug release from a delivery device. But for now, they're taking things one drop at a time. This is Lauren Wolf reporting for Chemical and Engineering News.